be a nice guy.
Well, when I do, I don't want to do production, but I just run develop
Pretty good, how you doing, Rob?
or configure for my environment on
Oh,
the
man.
machine.
You know, I gotta donate some money to you guys, cause they're.
Ask Claude, hey, look, see what's going on with this. Oh, dude, make these changes.
We
Yeah,
don't need
yeah,
full
like
step
make
how
food.
we bring this site.
So what happened was we rolled out XDP
The deal is
or
we
we
don't
enabled
have,
XDP
we're not getting sponsors, so
for
this one today.
all the nodes
I'm
in
paying out of my
our shared
pocket
services
and I'll
cluster,
reimburse with
Okay.
CNCF.
and that
And
caused
this
cascading failures because
money
once
is
we
like
did that,
150, with
pods weren't
150,
able
that's what
to
we can get.
communicate with the centralized
side
service,
was like
and so then
$250.
all of those that depended on that centralized service started to fail, and then
But let's see if
the
we can
things
get
that depended on
sponsors
those
coming.
things started to fail, and it was just
So it messed up the CNI traffic?
something like that. It was not,
Okay.
yeah. Both inside the cluster and outside the cluster weren't able to communicate with these centralized services anymore.
Yes, yeah, totally.
But you only use it for L4 traffic, right?
We use it as a replacement for kubeproxy and VPC CNI.
Okay. What do you use for L7 or?
I think we have an NLB for that particular service, but we usually use ALBs.
Oh, okay. I use
Yeah,
this
we got three types.
We did use Istio
Veggies and
not too long ago, but left it because of cost reasons, I think.
Because of what?
Cost reasons, I think.
Cost?
Cost.
You use ambient mesh, it doesn't use as much resources.
Say it again?
Ambient mesh doesn't use as much resources
I am organized.
as the older version.
It's been 4 weeks
But
without doing
the
much
functionality is
started the job
like
no,
apples to apples.
I'm not as familiar with Istio. I just know Zynga has a history of using it and then decided to move on and go
I miss my friends.
100% in Cilium.
We are all together.
Yeah, I guess you
It's
could
like
do,
door break kind
yeah,
of
you
thing.
could do L7 traffic with Cilium.
Broadcom, we have.
I mean, I
AWS
have,
load balancer controller, I think, is what we use for our
Well,
ingress.
I'm sure
So-
there's no politics because I joined as an engineer, not
yeah, so you
not a
can do-
project manager,
so
not a leader, so.
I use Cilium for load balancer for like 192,
They open the
Traffic.
tickets.
right? Which I
Hello,
basically have my
welcome.
own, I use Pilot and DNS.
We also use notebookal DNS on top of all of this.
Oh, okay, okay. But for, the nice thing about Istio is you only have one 192 address. And so it just knows where to go.
Every single day.
It'll route it to the right place. And then everything is cluster IP
That's the total shop.
10 dots instead of 192 dots, so.
I'd always said that of all things Kubernetes, and I include Istio, my weakest area has been networking,
It's
Yeah.
like 35
and now
minutes to 30 minutes.
I have.
You have no networking, yes.
What's that?
What's that? You have to know a lot about networking, yeah.
I'm learning.
Yeah.
When I moved to San Diego, 17 miles drive. Good day. Drive. Yeah, no, 17 miles. Good day, 45 minutes. Bad day, 90 minutes.
Yeah, so I'm actually an organizer.
Oh, okay.
That's one.
For Kubernetes?
After that, I was like,
Come
can I
on in.
work remote? They said, no, you need to be in the office, even though I control the server is remote.
Pizza, there's sodas and beer.
Hello, are you new?
Yes.
Cool.
Where'd you find the meetup?
I'm subscribed to the Kubernetes and CNCF events in Austin.
Cool.
Nice, that's it.
Yeah, enjoy.
We got
Pizza,
pizza, we got
beer.
What?
Ask them, they have one that they expired.
Hello.
Early bird.
Welcome. We're gonna have like 15 minutes before we start, so we have people get acclimated.
Exciting topics today.
joined, but now it's Broadcom through and through.
So it's Blackout?
No.
No.
VMware was a dream, man. VMware was perhaps my best job ever. It was nice.
But VMware got purchased by Qualcomm, am I right?
Yeah, okay.
So now it become horrible Tom.
So now it's like 3-5 times more expensive, so it should be 3-5
Almost
times
10.
better.
Yeah.
Okay, okay.
So what they did, back in the day, if you wanna just vSphere, you buy vSphere. If you wanna NSX, then you buy NSX. Now we just get VCF, which is the whole, there's only one product. They bundle it, and then it's up to you to use all the components online. So, but this stock is really good. That's why I joined them.
Wow. Tuesday. You see, tons of people on Thursday night, nothing to do. Jesus nearby.
The few former VMware people now. There's Sadia Copeland, there's I think Eric Young here was with them. What's her with Dan Nichols maybe? Might have been a former VMware person.
A lot of people left. Crazy.
Kubernetes?
Kubernetes,
Kubernetes, come on in.
the
Smelling
requirement
nose.
number one, we need to eat pizza and avoid to introduce yourself. Just kidding. You're at the right place, Kubernetes.
Usually start 6:30, so because you know, with the traffic.
Yeah, thank you.
Rafa, do you know if Vishwa was coming?
I'm one of the co-organizer, Raphael is one, Austin is one, Chris is one, and we have others. So we meet regularly, monthly, we got on,
Next month, we should do on the 23rd or 30th. What do you think?
23rd, we already have the rope up.
Okay. You want to CNC?
It's me too.
Tonight?
Well, I've already
Yeah.
disappeared,
No.
so what's the next?
I'm just offering everyone because you never know what each one. I don't mind to MC, but would you MC next one? Okay. I don't wanna be just a man.
We all live here in Utah. And we'll have recording capability
Over there?
I already did a dry run, got with the IT person. We are gonna meet half an hour before and get everything set up. Do another run for your day of. And the only thing to keep in mind is the mic situation. So what I'll do is we'll do a Zoom meeting.
Okay.
And they'll share their content. It'll show up on the screen. The way that the Zoom meeting will pick up the audio is if they we use the mic setup. So if people in the audience are gonna ask questions, they need the mic. The only downside is the mic's always hot.
What do you mean hot?
Like as soon as you take it off the thing. I think so.
Okay, how you doing? Since I have both of you guys need the same piece of document that Chad got signed by Cloud. You know what I'm talking about?
No.
Chad put together a document saying that everyone is on
I saw that.
So the thing is behind this doc that we put together, spoke to him, he was little, maybe for lack of a better word, uncomfortable having cloud native board versus KCD organizer, so he put the document saying everyone is the same. And then I spoke to him this weekend, and I said, should we prepare this for the other people who wants one? So I'm offering to you guys.
What's the document?
It's just saying that everyone has the same KCD. I don't wanna make a big deal or anything.
No, I think
Subject to
it's
this.
mainly that I use cloud native Kubernetes to communicate with the external parties.
Yeah.
Then we are responsible for the part of that. I think I'm missing.
The root cause, I'll tell the root cause. Chad as an organizer felt a little bit weird in certain discussions about changing contracts with the sponsorship, just with the cloud native access board, the 5 so I was a little disconnected when I saw the document saying that everyone in the organization is the organization, regardless if they're the board or not. So I signed.
Did you put it in the KCD technical organizer?
There is some. But here's the thing, I don't want to make this a big deal. That's why I rather purposely come to you guys face to face and offering. If you guys feel anything the same feeling that Chad had, that I'll give the same document. I know.
Before TT proxy,
I know. Especially you because of the thing with so that's why I'm offering the one.
I mean,
What I didn't want is go and center everyone without having this conversation, and some people completely believe it's like Chris.
yeah. Well, not that I don't care, I just like, I don't know if I'm.
It is something that we have to figure out
So
eventually.
what I'm saying is not like it's everyone in the organization just sharing everyone, like especially you guys are using the working.
So I still have to have a conversation about working. So you guys are working towards my opinion. And Chad. So if Chad felt a little weird about on that document, maybe you guys want the document too.
I wanna see the doc,
Oh,
I'm hoping that it'll trigger my memory a bit.
I'll send you over Slack.
So last week, my first week on call, I did it at 6 in the morning, 11 a.m. and all the way past 5. So like my brain is a little fuzzy. Yeah, so I'm like,
I know, dude. And me, I was spending, it's my 6th week in the job, in the new job. It's just different. I got used to it, like with the dynamic of the team, very transactional. People who use good morning, good afternoon to anyone. Very, okay, let's talk. let's talk about this Scrum, and then the technology is pretty cool. The controller controls you and I have a lot of fun. But it's just different. And I was getting a little bit burned out. Yeah, because I was trying to do so much. And I spoke to Chad on the same conversation. He said, our main competitor, SAI, they had so much money to learn.
I mean, that's how they got high power.
They said they threw a party, hundreds of people, all this kind of stuff at Kumar. I can't, by myself, find this shit. I was getting stressed, like, Good.
Okay, so what was the conversation around it?
The conversation was Chad.
It's like it's starting to come back, but
Chad was little off when certain decisions so he felt there was like two levels of decision. Put that together, and that was him, driven by CNCF. Just make sure everyone has the same stake. I agree. So yeah, which is required not the end. Certain people outside of native Texas find that eventually they're gonna do a lot of stuff with CNCF. It's fine, but we are doing CNCF, we're getting money because of the CNCF, and I don't see this changing. Well, that's true. Well,
and to your point, we're getting money from here.
exactly. We're getting money from CNCF, but all this money, they're not. That's Chad's point. That's Chad's point. So, just that's why I want to have this conversation with you guys. Step up. We already bringing this up in the Slack chat. Because I want to put this behind us. Yeah. As a non-profit,
The education agreement protects the role.
like, if you guys make a decision based on the calls or not, because that was a little bit of the genesis for this when change the contract was sent without
But we do need to do that for changing contracts.
you still have to do it.
They're the ones that
Yeah, but I didn't read as much. There's a piece of paper. I signed it. But if you guys want, right now, you get
so like reading the document, it's very technical, so I would say to share because it's protection for us.
yeah. But
then integrate all the group members, make them as participant of that cloud native, that in the document, that's also
So the reason we only had five, because we
not the board, not the board members.
that, and it needs to be part of the
Not the board members, there was a small way that.
Yeah, we can do that.
Employees,
Yes, we can do that.
yeah, that's enough.
And
Come on.
I wanna have this conversation after this meeting to not get distracted.
You do it after.
But here's my opinion. Cloud native is a good thing, not the other way around.
Because we need some process.
That's, some people think like, okay, we gotta get money, we can create a whole, brand event, whatever. Honestly, I don't have time for anything besides CNCF.
Yeah.
If someone wants to do it, geolocation, the majority is fine. Me, Rafa, I don't have time. I barely have time for K8s. And here, we got in this conveyor belt that we more or less, we know what to do, right? Yeah. We know, we got here, WS2, there's a venue, we got sessionize, we got sessionize, we got,
This is
yeah, the only thing is getting the speakers in time to create the art, and now I have Kumar doing that for me.
I've been wanting to like automate this generating the art and
I just got the prompt. I got the Chrome extension. So launch Chrome, do all this kind of shit for me. The only thing that I haven't done yet is having the Chrome extension to the events. That I did by my
let's have a special. I've been talking to Andra for 8 years now about helping her that's why
well,
that's a good process.
Okay, let's get started. Let me, so, Marsha, any day you want to see, let me know. I told Chris, because I don't want to. Next day. Speakers for next month?
Yeah.
Everyone decides to do.
Yeah, there are 2 people, right? I'm more concerned if you spill over more than being sold a guy.
And then he has some.
Yeah, for sure.
You're good.
Nobody gets to be part of it.
That's why, so
Oh, yeah. No, it's just fine.
We're gonna have a lot of pizza left over. When you feel new, get this side pizza here. It's hard to prevent. It's hard to prevent. Oh, I just touched my, I'm fine. Pretty good.
Forgot to talk to Angel. The third teacher for KCD. He reached out to him today, and he's good. So we have all of our speakers now.
So we got Ian, we got Katie.
Hey, sorry for interrupting, Chris, is there water at the bottom or?
I forgot water.
Oh, no worries.
Alright, let's get it started, folks. Just, some public announcement, we got the validation tickets, before you start, wanna discount, come to see one of the organizers, gotta put some over here. Thanks for coming. We've been doing this for a couple of years now. My name is Rafa Brito, I'm one of the organizers. And let's get started. So first of all, many thanks for Station Austin. You're not crazy. You're the Capital Factory, but they're rebranding to Station Austin. And that's the second time they changed the logo in 3 months. I think they're still like trying out, but thanks to them. We have the meetup here every 4th Thursday. So our meetup is every 4th Thursday, but starting this year, we are rotating locations. 1 month here, downtown, so we cater South Austin, and another month, North Austin. So last month was at WSO2, next month gonna be a Zynga at the Domain. Today's food beverage is brought by me, but yeah, if you got more sponsors, I promise you're gonna eat side pizza. That's my favorite. But you know, I am ambassador from CNCF. They give $150 every 6 months. That's how I all procure the money and pay for it. If you want to donate money for us, best way is over GitHub sponsors. You can get even a badge. You can stick on the GitHub handle. It's pretty cool. The funny thing is, they cut 1099 in my name. Then I have to tell my tax accountant this is all for pizza, so he put some numbers in. I don't have a slide on this, but we do have a non-profit called Cloud Native Texas. When they say we, organizers of KCD, and I do have a slide about KCD. Eventually, we want to have the non-profit manage financially the community groups. Not yet, so you have to iron out a couple of things. But why I'm saying this, because that shows the organization of the volunteers in Texas. All right, I see some new faces. I want to put anyone in the spot, but this is a safe place, it's a very welcome. Everyone comes here to learn, no matter what part of the journey on the cloud native you are. If you're here have no idea about Kubernetes, I guarantee you came to the right place, because that's the whole point of the community group, is welcome new members. If you teach, you have to learn first. That's the law, universal law. So if you're here to learn, eventually you'll be here presenting as well. So any takers to introduce yourselves? I said my name is Rafa Brito. I see some new faces. You know, before that, the organizers, please stand up.
Hi.
Introduce yourself.
Yeah, Sandy Chow. I've been at this group for like over 2 years, new to being an organizer. My expertise is talk a lot, nonsense, but make people laugh. No, something technical, something business. So.
And run, right? You run?
Yes, I like to torture myself and I run and learn. That's my brand name. So I listen to like any podcast or like tutorial on training on technology. While I'm doing my half marathon, full marathon, ultra marathon trainings. So you're welcome to run with me and learn.
Yeah, I'm Chris. Kubesternaut. I've been organizing with Kubernetes Austin for a little over a year, and also a KCD Texas organizer.
So my name is Geoff. So I'm new to organizers. I'm also a Kubesternaut. So I'm lead architect. So do a lot of things.
And Miroslav, just a little time he joined already, showed a lot of work organizing the sessions and the speakers and so on. And by the way, if you guys want volunteer help, you know, find us, and we always gonna find something for you to do. Other organizer?
Yeah, so Harsha, so I'm also part of Kubernetes Austin and KDS. So it's really welcome for everyone can join with us. It was really cool.
Right. Anyone else wanna introduce yourself?
I'm new to this experience. My name is Mike Lewandowski. I'm founder with BIM Reality Technologies. I'm building an infrastructure for digital twins, but I came here for education more than anything. But I'm also looking for co-founder in the AI intelligence space as well. If anyone is interested or wants to talk more.
Digital twins, you're talking about like AI twins or something, or?
So there would be an AI over the top of the digital twin, but the reality is that any physical object, any physical space, any physical being can be represented in a digital model. And basically, we build the infrastructure that supports that.
Adrian? We got the second set of speakers coming on. I was a little worried about you guys.
I want to pay for actually.
Oh, no.
I was only.
Well, yeah, we try to, so for people new at Capital Factory, there's the validation parking, if you go over there. There's so many floors over here, but because we grew over time, we're doing this almost for 3 years now, we secured this location, until we grow out of this space, which would be great too, but. Alright, anyone else?
I'll go over. Sure.
Alright.
My name's Keith. If I look like I'm sweating, I just got a suitor. I'm just here to meet people, network a little bit. I've got a fun little project. I'm kind of framing South by Southwest like a nature documentary. It's a little ridiculous, but it's kind of fun. I've done some technical things, nothing to really brag about, but more or less, kind of here to confirm and verify some of the things I've been working on. I'm not exactly trying to pitch or throw it right up front yet because I'm still working. I don't know, besides that, I'm more or less just absorbing and transmitting.
We always be there, you know, compare notes, learn, teach. Right, anyone hired besides try to find a co-founder?
Yeah. My name is Reed, platform engineer, and I work with a company called Document. We do a lot of government contracting, and we are looking for a platform engineer.
Right, pretty cool. Anyone looking for a job?
I saw
soft looking, although everyone I talk to asks me if I want to take like a 30K pay cut, and I say not really, honestly. So, if you want someone that's, I don't know, if you want to hire me, it's possible. Just try to keep my pay around the same.
Well, mention engine, you guys can talk after. Anyone, any stories to share? Any new certifications in the house?
Oh, I have stories.
Okay.
There was a while where I was kind of on strike when it came to AI. That was for my own mental health. After time and space though, I started using Plot a bit. It can be useful for some things. There's a lot of stuff that would require a lot of copy pasting, find replacing, or whatever. It can save a lot of time on. If you want to go from a clean Terraform plan to a clean Terraform plan, just rearranging a bunch of toml and YAML and whatever, like Claude can help you do that because you can objectively kind of verify things. So yeah, I've been using it more. So that's kind of my story.
All right. Maybe you should come and talk some of those days about it. Right. I think I have a slide about KCD. KCD stands for Kubernetes Community Days. Only 4 in the United States, and it's going to happen next month in Texas, in Austin. So we do have tickets.
May 15th.
Huh?
May 15th.
May 15th. TCEA, which is near the airport. I kid you not, we hired 2 Longhorns.
We will have Longhorns for people to take pictures with on site during lunch.
Yeah. We're gonna have happy hour at Meanwhile Brewery. If you haven't been there, it's an amazing brewery. What else we got? We're gonna have cowboy hats.
Cowboy hats. Instead of the usual t-shirts.
Is this broadcasting live?
This is broadcasting live, I guess, right?
Yeah. That's the camera.
Oh, that's the camera. I cannot say anything sensitive.
We're trying to figure out how to.
But yeah, KCD. We got a couple keynote speakers that not published yet, but some people from CNCF and some people very active in the community. Right. Very quick, New Iron is our partner. If you are looking, want to refresh your resume, reach out to her. She's great. She helped me. And she's based here in Austin, and she knows the local market and all the Kubernetes openings. All right, we already introduced the volunteers. That's the CNCF Slack. Join, that's mostly our communication over there. And let's go to the talks. Thanks everyone for coming tonight. I am going to talk about AI RAG agents on Kubernetes with NVIDIA GPU. So I've always seen a lot of presentations where they talk about AI, but like, why not have it run on Kubernetes, right? Like that's what we are. So here we go. First thing, a little bit about me. I'm an executive director of CBS Health. I run a software team of plus 100 engineers. We have very big Kubernetes presence. But what you're going to see today is actually my own home lab. So,
agenda, motivation, and cost. Like, why would you want to do this? We have public APIs. An architecture overview, some discoveries, things that I've figured out that I was surprised about, and then of course I did. So time-wise, start there. Data privacy and compliance, right? Everyone's concerned about public LLMs. If you're running on your Kubernetes environment, it's all going to be contained in your environment. Cost predictability. You don't have to worry about like how many tokens you're spending because, again, it's all in your environment. Full model customization. Maybe you want a particular model optimized for a certain scenario. Yes, frontier models can do everything, but do you really need a frontier model? Lower latency and owned uptime, right? How many times has Claude code gone down for you? Yeah? Okay, a few. And it's just really cool to do it yourself. That's the most important thing. Alright, so cost comparison. Cost of AI. Alright, I can't quite see this. So, token cost has obviously gone down. I think it was around, what is that, $60 per million in 2022 to like 0.08 cents, and continues to go down. But the usage is massively spiking, right? As the models get better, they use more tokens, right? So the costs explode. So we're looking at a 3,000% plus cost increase. So that does present some challenges. But now if you look at the cost trajectory of, for example, the red line, which is your frontier models, yes, they're going down as well. But these other lines, like let's say an NVIDIA H1 server, there's a gap forming there, right? Like the cost of the hardware is also going down as well. So it makes it more compelling, if you are cost sensitive, to consider this as an option. And plus the number 5 is also very cool to do it yourself. Yeah. Alright, so more on costs. A lot of people are getting big bills that are shocking. This little company here, $50K a month. They're like, whoa, what's going on? This guy, he says between the inference costs, what pay AWS, which is ginormous, between our cost with Cursor, Anthropic, we're spending millions. I know a big corporation that might be dropping Cursor because of the cost, right? Like, and you're starting to see that more and more. Okay, that's great. So, when would I choose one over the other? So, like, for most of us are using, like, let's say Claude Code for coding. If you're doing it less than 2 million tokens a day, you have variable unpredictable load, you have no ML engineering capacity, you haven't hired that awesome platform engineer that can build all these things. And you need frontier models, right? Like, if I'm doing some complex coding stuff, I'm going to use Claude Code, right? And then if it's speed to market is critical, which for a lot of startups, right, they have to consider that as well. So you'll want to stay on the frontier models. But let's say you're really into it, right? You're spending 10 million to 1 billion in tokens, which is a lot. You can achieve at least 50% utilization. And And I don't know, like, I talked to several companies that, are like, oh, we're gonna buy our own NVIDIA GPUs, but they don't even use just a fraction of that, right? So you have to be smart on the resource consumption. You have some ML DevOps capacity, you need that data privacy, like especially like for us, we're actually in the Medicare space than CVS, so that's definitely a consideration. And you want cloud native scaling, because we all know that cloud native is cool, and we want that. So that's when you would consider doing it yourself. Any questions thus far?
Sorry,
Yes,
that's
sir.
EKS, AKS, but you mean self-hosting?
Well, yeah, I mean,
You mean?
yeah, but, I mean, so, that's kind of another discussion, like, should I have my own Kubernetes versus AKS, EKS? Problem is, there's not a lot of good numbers, right? So, like, we have advertised numbers for, like, what is H100, H200, right? So that made that part a little easier. Okay. So, my RAG-enabled chatbot, kind of what I built to kind of demonstrate what it takes to actually do this. And it was way more involved than what I thought it was going to be. So first thing, bill of materials. What's involved in this app? So there's the front end, which is React. I went with Fast API Python because honestly, like, you have like LangChain, LangGraph, VLM are all Python. So that was the easiest thing to do. The vector database, Milvus. I originally set up Milvus distributed with a proxy, but like for Homeland that takes a lot of resources, so I just went with standalone. I went back and forth on embedding models. This one was pretty lightweight, and I'll get into kind of where these things live. And then I was kind of going with Quinn models at first, which is Alibaba's, but I ended up landing on Nematron, which is NVIDIA's, and I'll explain a little bit that. Mostly it was, the inference was pretty robust. 56 tokens per second. I think Quinn was in the 30s. And then, of course, storage for chat history, etc., PostgreSQL. So there's a lot of infrastructure that, by the way, you can all run on Kubernetes that's involved in this setup. And since we are, a CNCF event, call out the CNCF things that are involved. So we have Kubernetes, Istio, actually ambient mesh, Kita for the HPA part of it, and then Backstage for cataloging, and then external secrets operator. If you don't know what that is, you can put your secrets in Vault or HashiCorp Vault or Azure Key Vault and pull those in, which is a really nice feature, and of course customize for all of the manifests. Alright, so some of the dependencies, again, there's a lot of Python libraries. The interesting thing is this is a very stable setup, right? So we do a lot of, hey, we want to be stateless in ephemeral transient in Kubernetes. Well, that's not the case with this, right? It wants to maintain state. But then you also have to say, okay, well, how can I maintain state and have resiliency, right, and scale? As things scale, things kind of move around in the Kubernetes world. How can I maintain that state? So, a lot more on that. LangChain, pretty much everything that LangChain offers, I pulled in there. And then for the document embedding, I used PyPia to create the embedding. All right. Any questions on the software? Yeah, let me get into the architecture piece a little bit more, and then I'll show it. Yes, yes, sir.
Have you run something that has an NVIDIA card in your AWS home lab without deploying bankruptcy?
I'll get to that. Good question. All right. That's the device architecture. So the first thing, the most important thing, you need a Blackwell GPU. So I have convinced my wife that I need one of these. It was either a new lawnmower or a DGX Spark. So it's got a server class Blackwell GPU. It's got 4 terabytes of SSD storage, 128 gigabytes of unified memory, and you will need all that memory, by the way. The storage, not so much. Blackwell, definitely. The other cool thing is it's got a 10 gigabyte port on it, and you can chain them. So, like, if you really, really want to start spending a lot of money, you can chain these suckers together, and you can run some very, very large models. So, I'm not willing for that investment commitment yet, but if you really want to kind of kick the tires, you got to have one of these guys. Yes, sir.
How much was it?
It's well, so I bought it when it first came out, and it was $4 grand. It's more now. So, yeah, listen, like it's a really nice lawnmower, or this. All right, so that's okay. Everybody's done now. It's like, yeah, okay, I'm out. All right, but you think about the price of cost of certification, right? Like, what's that going to do for you? Like, if you get this, you can actually play with it and kind of build it yourself. And for me, like, that's how I learned. So that also helps with justification. All right, architecture. So, Istio Ambient Mesh, and actually I have Cloudflare in front of that. So the front end running on CPU, back end on CPU. So with the statefulness, there were some configurations you can do with Istio to essentially say, hey, don't evict these. I mean, obviously, if you will restart, you're going to lose the connection. So there's a lot that you can do there, and then I like caching with Postgres kind of help as well. Kita to kind of scale out. There's probably more, like I didn't honestly put I probably should like run K6 and put some serious load on this, and then see how it handles that. But I would say just for like normal Kubernetes scheduling behavior, like I've put a lot of annotations in place to kind of prevent it from doing things that it would normally do. And and the load on I've got my home lab on that now. 96 CPU and 300 gigabytes of RAM of just like CPU power. A lot of Raspberry Pis. But some of them are pretty loaded, right? So anyways. So that, and then for the back end, the Nematron, which is on the GPU. So the cool thing on this is you can do there's a GPU operator that you run in Kubernetes, and it basically you can configure it, and in your manifest to say, I only want GPU workloads to run on this. You do need things like Cilium, Istio. I'm doing like Longhorn for distributed PVC. So there's a few things that still need to run on it, but for like your basic workloads, you can kind of control that. Then it also makes sure that CUDA and all the other stuff that need to be exposed, that helps with that. So that's a big part of. So it's from a deployment perspective, it's just basically a normal manifest, and you say, hey, I want this image. your container registry will get big, by the way. Like, you know, I went ahead and did like a public one. I was paying like, I pay like $5 a month. And then I started doing this and then it like doubled. And I was, oh wow. So I have a cron job that kind of cleans that up. But, yeah, those are big images. And it takes, it takes about, I would say like 20 minutes to download that thing from Hugging Face. And so what I did is if I got a, you know, if it's got a restart for any reason, I don't want to take that hit. So you can cache the model in PVC, and so, or persistent volume, and then that, I think that brings it down like to 2 minutes. But you know, you have to tell it, say, hey, don't pull from Hugging Face, get it from the cache. Now, if you ever lose your cache, then you have to change that annotation. But that's kind of an annoying thing. Actually, I'm like, should you check the cache first? It didn't work that way. Embedding is on CPU, Postgres, Nova standalone. So I thought this was interesting. The actual usage of the model is 72 gigabytes of GPU, 4 gigs of RAM. Even though the weight of it's actually 15, but if you look at all the you know, GPU, memory utilization, KB cache, CUDA graphs, the CUDA graphs actually take a bit to spin up. It makes a huge difference on performance. When I do the demo, you'll see how responsive it is. Does that answer your question? Yeah.
It's hard to read. Is Milvus also using the GPU?
No,
Sharing
CPU.
purposes.
I'm all CPU.
So there's only one application using the GPU, which is the Niehaus?
Yeah. But it's big. Okay. Software architecture. Excuse me. All right. So this just gives you another perspective. Web UI, WebSocket handler, land graph, the chat, obviously with Niehaus, generate embedding models, Postgres and Modbus, and then yeah, it's kind of similar thing, gives you a little bit different perspective, and then query flow, user message. I am using JWT. I actually created an authorization service because why not? And so when you actually log in, I have my own token. The interesting thing with a WebSocket connection, you can't, at least I couldn't figure out how to establish it initially with the token, so it kind of, I mean, all my endpoints are secure, but it basically establishes a connection, and then it passes the token down to the front end, and then it uses that for the traffic. So once you get the connection established, then it secures that interaction. I could probably figure that out if I tried harder. Right, in land graph, reason selected source from the config. We add an embed query that's created, vector search of Milvus with that special indexing, and that was another thing too, like I played around with a lot of different indexing. And actually originally I was using like MCP. Everybody uses MCP, right? It had like 20 seconds to 23 seconds. I was like, so I just got rid of it. So I could go directly at Milvus. Filter for relevance score, threshold. That, it was interesting. I'll talk more about that. Format, context with source attribution, render the system prompt with context. And even this part, like, you have to be careful on how another one I didn't. But because it had that full window, it said, oh, you know, I got enough token matches that I should respond to this. And so it will respond to something that's not related to the document that I uploaded. So that was an interesting find. Single LLM call, says prompt, use questions to response, and then of course WebSocket. And then token usage, I send back. So that's the query flow. Discoveries. Okay. So Kubernetes allocates the GPU as a single, indivisible resource. Oh, shoot, I forgot to change this. So Nematron deployment claims the entire GPU, blocking any other power from scheduling GPU workloads. So what I didn't realize, like us that are in the Kubernetes land, like well, we can dice and splice CPUs like all day long, right? Can't do that with GPU. No, will not do it. So I don't have one. Like the operator won't even allow me to schedule, right? If I try to deploy another model, it's going to see that there's one already deployed. It's going to be like, nope, not happening. So what do? You add more complexity. So this is kind of, and I haven't done all this by the way. So these are kind of levels of complexity. So NVIDIA GPU time splicing. So time splicing lets NVIDIA GPU operator advertise a single physical GPU, but you have multiple virtual GPUs, and the pods will take turns on the GPU, need context switching, no code change required. So that's the easiest, but there's a hit. Yes, sir.
What's it?
Do not.
I'll look it up. I saw your name.
Yeah.
It's also on the meetup event if you go on meetup or CNCF.io for this event.
What do you do now?
Geoff will be.
It's I was on the earlier. I'll find it. Thank you.
Alright. Sorry. You got a water. The allergies getting everybody. Yeah, it's like alright. Alright, so that's a simple one, but there's a hit. And then the next kind of level of complexity is NVIDIA multi-process service. So NPS enables true concurrent GPU kernel execution for multiple processes. So that sounds more like what we're looking for, right? Rather than time multiplexing, so better throughput than time slicing, because you take a hit on that. When multiple workloads are actively simultaneously, like we have two things hitting the different models at the same time. That's the next level of complexity. So you imagine I have more to do with this. K-serve, which is open source for multiple model GPU serving. K-serve provides a Kubernetes native model serving layer with auto-scaling, canary rollouts, which is kind of cool, and model mesh for multiplexing models on shared GPU infrastructure. And then last, VLM native multi-model via LoRa. So if your agents are fine-tuned, if they're fine-tuned variants of the same base, so essentially you have a base model, you have variants of that, VLM, which is running in my background service, or background microservice, can serve multiple LoRa adapters from a single base model, 0 additional GPU memory per adapter. And if you wait another week, there'll probably be another option. Alright. Next discovery. Forcing document context on responses is non-trivial. The system uses a defense in depth strategy across 5 layers. So, mandatory retrieval, I said only go vector, right? Prompt, system prompt with context and explicit rules, like, so you kind of add stuff to say, only get it from the document, don't do anything else. That's kind of the short version. Relevance threshold, right? So I had a 0.4 cutoff. And by the way, every model is a little bit different. Like when I had the Quinn model, I had like 9 layers to get through it. The Neutron seems to be a little bit better. It's a newer model. And the other thing with Neutron, it is optimized for the Blackwell GPU, which is another benefit. Architecture, local models, self-hosted database, single pass pipelines, no web access. And then also playing around with the temperature and your sampling. So to prevent creative hallucinations beyond the context.
I have a question from the previous slide.
Yes.
So these approaches are essentially if you want to share the GPU across multiple processes, kind of like want to deploy multiple GPUs.
Yeah. So for example, my next fun project that I want to do is have an army of AI agents like that go off and do things, right? And so maybe I don't want to use this one model, or maybe I want to have different processes sharing the same model, right? So depending on what you want to do, you can enlist these different levels of complexity, right? But as far as the GPU operator, right, for a single GPU, you can only have one if you're just doing just a basic deployment.
Did you explore, so NVIDIA has this thing called MIG, multi-instance GPUs, you can essentially partition.
So, okay. So when you get to server class stuff, right, like your H100s and 200s, there's additional firmware things that they offer. But like now we're talking the price of a house. So it's like house, server. Right? Yeah. But if you want to do this, right, which I would say, 4K is painful but approachable, probably, like if you're really committed. These are the options that I'm aware of. Now, could there be another one? I don't know if the one you're talking about works, but I believe that is, at least on this class, I believe it's on more the server class.
Yeah.
Okay, good question. Yeah, and I think they're definitely doing a lot at the low level firmware to kind of help with that. You know, I haven't read anywhere that they're doing it like in the GPU chip itself. I think I've seen they're kind of getting into the CPU market as well. But like that, I don't know. But I don't know if anyone heard anything. No? Okay. All right. Next thing, conversation state management. So to the gentleman in the front there, state management. There you go. So non-trivial. Yeah. So these are all the different things that I did to kind of deal with state. So pod eviction, servers, websites. So solution, set safe to evict equal false. JWQ auth on WebSocket upgrade. So keep it session aligned with the token. Conversation state lost on pod restart, which would happen. The line graph has a memory saver, it is a process memory only. So I flush it to Postgres for durability. So line graph's memory state. So it can reconstitute itself if the in-process memory goes away. What else I got here? Auto-scaling disrupts active connections. So root cause, scale down terminates the pod, pulls it up socket, scale up doesn't rebalance. So Kita with conservative scale down and aggressive scale up. So that helps with that. single user exhaustion connections, no built-in WebSocket connection limits. So you do per user server-side tracking, and then Istio, and it just goes on and on. Istio partial response, state LRU caching, oversized WebSocket messages, and health crows. So I have all this actually documented in the repo as well. Before we get to that, we have a demo. Okay. Oh, of course. One second. Yay. All right. So it is actually sparkchat.bytetheory.com. And you go to the auth. And then I did that one. Here we go. Okay. Let me get my code. I don't want people, this is publicly available, so I don't want people taking down my GPU. Add some additional security there. Alright. Hello. Okay. So context of this guy is all about the NVIDIA Blackwell, so I'm gonna say, right, what makes the NVIDIA Blackwell GPU special? So I was thinking about it. Ah! That was not too bad, right?
Cool.
Alright, so, but then, like, if you get more targeted, so let's see, here's one of these. Cause that, you know, that had to look at everything. It's like, okay, let me figure out what makes it special. I used 1,606 tokens. So that's the other thing too, like different models have different token consumption, right? Like some of the others I was looking at that weren't optimized for the Blackwell were in the 3,000 range. So that also has an impact. If you say like, what is, let's see here. What is that? I don't know, what is that? I don't know what that is. Boom. Dumps it right out. And then what did I say? Okay, what did I say? Who is the president of the thing? Or maybe who was the first president, since that's just more historical. Who was the first president? Not exactly that. You wouldn't want to try something? No?
What did you index?
Huh?
What did you index?
What did I index? Oh, good question. So let's see, where is that?
So that's the question. You asked it.
Yeah, that is a question. It is a question. Like, where does this all come from? I was thinking about that too. It's like, I should probably. What's here? Golly, man. Too much stuff. Alright, let me try. I know it was on Blackwell. Ah, there it is. That is not what I opened up. There it is, okay. Yeah. So I index this guy right here. All about my favorite GPU. So it's got about 57 pages of stuff. So that was, I think to 133 chunks. It does take a while to do the vetted. Yeah. And I experiment a lot with that. So yeah, so that's what it's all indexed on. Okay.
Yeah, so you wouldn't expect it to know who was the first president then?
Ideally, yes.
Ideally,
Yeah. Yeah. And then, okay, lastly, GitHub repo with everything that you saw today. I don't have, the auth service, Milvus, Postgres install, but pretty much everything else is there. Yes, sir.
In there, I try to scan the code, you say the code is not working.
Are you kidding me?
Yeah. Am I the only one?
I gotta say.
No, we are all doing the same thing.
Yeah.
Oh my goodness, okay. Alright, let me fix, I actually tried it a few days ago, but yeah, let me fix it and then I'll after the next talk.
If you have Chrome and you pull up the GitHub repo, you can just right click and create the QR code real easy.
Okay.
Learned that recently.
Hang on just a second. I think we need to.
Oh, we can.
So how does companies get set up their racks?
So if you right click,
Okay, where
anywhere, just anywhere on the page.
Really?
Mm-hmm. And there should be in Chrome.
I see that. Yeah.
Create QR code.
Great QR code. Oh my gosh. Alright, everybody.
That's cool.
Can you get that? Oh shoot. Okay, hang on. I did not know that was a thing. Oh, here. Can I copy it? Or maybe I downloaded it and then open it. There we go, look at that. Boom. Is that big enough? Got it?
Is that Chrome thing?
Mm-hmm.
I didn't know you could do that. That's cool.
I
learned something.
I learned it like last month or something.
That's probably the best thing I've ever
Yeah.
So how do companies organize a rack?
How are they doing it?
How do you see it?
How do I see it? What do you mean by organizer rags?
Like, you have a whole bunch of internal intellectual property that your company has. And you want to throw into an LLM.
Yeah, I mean, it's,
how are you supposed to handle that amount of data? I mean, how's it supposed to be given to you?
yeah, well, I mean, so all that's gonna be vectorized, right? And so it's really on your inference model to make sure that it's using from the vectorized data, right? So I think to me the bigger challenge isn't so much that piece of it, but there's like a security piece that says, what if there's data in there that's sensitive or maybe isn't applicable for that particular user, right? So I'm looking at some enterprise like versions of like Live LLM and other things that kind of carry with that some permissions on what data and is supposed to kind of observe that and make sure that it doesn't come back. Like, I can't say that I've like experimented with enough to say that that is like solid, but it's a huge issue, right? In my opinion, and especially when I think about like healthcare data, like, I guess the safest way is to have different vector data stores, like maybe like per person. It says, okay, this person can only, this is this person's database, I can go there. But, I'm sure someone smarter than me has probably figured that out. But it is something that kind of goes in my head, kind of how that should work.
And we gotta move on to the next speaker.
Okay. Thanks, everyone.
Thank you.
Okay.
What we can do is put your presentation on the Slack channel after. Can you help me?
Yeah.
Oh, okay. Folks, alright, thank you so much.
Yeah, thank you.
Next one, come.
Sure.
Alright. Give me you guys doing, in 30 minutes-ish?
Oh, you already did? Okay. Just jump in and slide. Okay. Yeah.
So where's the connector? Oh, this one. I got it. Okay. Fair enough, guys. So our second talk today. So let's talk about the topic first. Do you guys know what is policy platform? Anyone?
Like the concept or the, is it a specific software?
No, like platform as a service, say. Excuse me. You want this to be good? Yeah. You have that time? You want it to be good? Fair enough. This is the number. Okay, fair enough. So, policy platform is actually a regulated industry like banking or insurance, right? So this is the core engine that maintains the policy, right? Policy life cycle, ratings, underwriting process, pricing, right? Everything. Like this is the core engine for many insurance, and also for financial industries, right? So today we'll be talking about modernizing the legacy, platform of policy services into cloud on Kubernetes at scale, enterprise scale. So I'm Joyjit. I have 21 years experience in IT industry. I started my career as a software developer and transitioned to project manager like around 11 years back. Here in Austin since last 10 years, currently working for USAA, United Services Automobile Association. That's an insurance company actually, right? So, and before USA, like I've been working for USA for the last 1.5 years, and before that I worked for them for around 9 to 10 years, right? So this is a brief about myself, and today, along with me I have my friend and co-presenter Samaresh Kumar Singh. So I'll let Samaresh talk about himself. Samaresh.
Hello, hello everyone. Thank you for joining us. So I'm Samaresh. I'm principal engineer at HP. I joined HP in 2024. I have over 21 years of experience in IT. So I worked in India for 7 years and then came to US in 2012. I worked for HP for 8 years, then Johnson Control and Eagle Eye Network. That is also in Austin. So yeah, so that is so currently I'm working on the edge computation and the edge AI platform. So from past few years. Prior to that, I was into the distributed systems and security. Yeah, so I'll.
Thank you so much. So let's move on, right? So a quick thing before we start, like we'll copy the speech, and then if we get some time, hopefully we'll have Q&A. And the first thing. Second thing is it's little theoretical, right? Because we are talking about migrating legacy to modernized platform, right? So let's start. So first we'll start with what is legacy platform, and you guys all know about this, I'm sure of that, but just a refresher here, right? So first we'll talk about the, I know what it's not about, I forget to turn on the switch. Okay, so monolithic architecture. You know, right, monolithic architecture, the biggest problem is single deployment unit. All modules refer one code base and one relational database. No service isolation, and as a result, the impact is like one deployment, and that causes system-wise risk because it can impact anywhere. A lot of regression testing, right? So next is slow release. Definitely because of this monolithic architecture, you have max go like yearly 4 releases, quarterly releases, even less sometimes, right? And long regression cycle, 3 weeks of regression cycle and 4 releases, say, and then you have a CAB approval process. Obviously, it takes weeks for the approval. They have a lot of documentation and a lot of processes, and then plan long downtime. If you remember, like 3-4 hours of downtime of services, right? It was coming on the website that our service is down for maintenance or something, right? So that old style deployment, slow releases. Shared databases, so every module reads and writes the same schema, right? So if one team changing the schema, it is impacting other, or at least you have to ensure that there will be a lot of regressions, even though there are some issues or incidents always needs to be there after every deployment. That takes a lot of regressions time. So that's the problem with shared databases. Batch processing. Do you remember like when you used to purchase insurance policies like 10 years back, correct? You purchase today, but you get them in tomorrow because of the batch jobs. So that's not a real time. All the, all corporation runs overnight through batch jobs. That means all policies and anything, any transaction you used to do, even if you submit a claim, it is to be the next day. So let's move on. Remaining 4 legacy problems, manual compliances. So for regulated industry, particularly for insurance and finance regulation, compliance basically is very important. So what happens? No audit automation or audit evidence gathered manually, basically, right? It used to, say, legacy world. So auditors chase people, just more manual, tracked in spreadsheets, emails, and no immutable logs, right? Status log, you have to create dashboards for all your audit and compliances, lot of time. Next is fragile recovery. So for an example, because of an incident, your production broke, right? So because of zero fault isolations and that takes a lot of time to recover, right? One failure brings down the whole platforms, means one incident, say. And once the incident is resolved, the full system restart required, right? And that means the risk of breaking production is huge. And there's just a data point like on an average in legacy services, the MTTR mean time to recover is like more than 4 hours for each incident, right? Vendor login, particularly for regulated industry, vendor is very important, and they have a login. They do not have REST API or no gRPC or no GraphQL, right? So they have a property rule in this, and no integration path. So communication happens to, used to happen through shared libraries and store procedure. So possible impact, zero external API input. So you are logged actually. Whatever vendor you use, say for example, if you know Guideware. So Guideware is a vendor for insurance. So once you acquire Guideware services, that's it. You are logged into that. And definitely, the latest one is no AML path. So because closed system architecture, which has no API-first interface, no container, and no GPU infrastructure, right? You cannot integrate your legacy service to AI. So these are the classic 8 problems in legacy world. And quickly move on to how you move from legacy service to cloud native or migrate to cloud native using Kubernetes. So for Kubernetes, based on those 8 problems, we define the non-negotiable decisions. These are the non-negotiable decisions when you migrate to cloud from legacy. So those 5 are, you can quickly see multi-team autonomy, cost optimization, which is very important, right? So right size workload, auto scale on demand, that is very important in cloud for cost optimization. Resilience and high availability. So zero downtime deployments, self-healing and fault isolation at the service level. And then 5th is regulatory constraints. So basically in regulatory industry, it operates under SOC2 compliance standard, right? So that means everything must be secure, traceable, and auditable. So there are a lot of regulatory constraints in particularly policy industries. Then AML foundation, right? It doesn't support I mean, the legacy, as we say, legacy services doesn't support any AML. But when you migrate, you need to have this AML foundation. For such as like, support GPU workload, model servicing, data backend orchestration, these are needed. So these something are non-negotiable capabilities that you need in cloud when you migrate, right? So how you do that? How you do using Kubernetes as platform foundation support all these capabilities. So let's see how you do that. First is the cloud native infrastructure, right? This cloud native infrastructure actually map all these three, capabilities. So the cloud native infrastructure actually have container orchestration that support auto scaling and auto scheduling, namespace isolation support, team level boundaries, GitOps using Argo CDC, right? That helps to deploy the code in Git. You can version the code and it is auditable. Service mesh using Istio, right? It helps to do platform level service to service communication, mutual TLS, and traffic routing. Next is governance and security, right? That directly map to the regulatory constants. So OPA and K8s policy engine, so that helps to enforce policies to workload during admission. That means if any workload doesn't comply the policy, then it will not be admitted. It will be rejected then and there, right? Role-based access control and audit logs that ensures traceability. Secrets using Vault that helps to centralize secret managements. Network policies that control service communication. And last is the AML platform, which actually creates the fundamental platform for AML or expand AML in cloud. So first thing is like in the AML platform, you need GPU node pooling. So that support ML workflow, model services using KSR, deploy models as scalable APIs, feature pipelines, feed real-time data to model, and agentic orchestration, actually support autonomous multi-step orchestration and intelligence workflow. Moving to next, okay, modernization strategies. We divided the strategies into 4 phases. This is the first. First phase is access and decompose. So you have a domain-driven. You have to do a domain-driven modernization before you move from legacy to cloud. So, and you need help from the domain specialist and architects, because you need to define how many domains you need. Each domain could be on microservice, right? So then you identify the boundaries of each domain. So each domain, what it does, what it should not, right? 4 things: map domain data dependencies, and then define API contracts for all these domains, right? This is the first phase. One lesson quickly learned here that don't define too many domains, because there will be communication channel too many, and it will actually cause a failure. So define 6 to 8 meaningful domains. For an example, like claims, insurance domains, say for example claims, underwriters, policy, right? This thing, billing, pricing. So 6 to 8 domains, and in any industry, like not even it is applicable irrespective of industry, right? Anywhere you go, like even in e-commerce also, make sure that do not go beyond 6 to 8 domains. Second is phase 2, containerize and build the platform. So service should be containerized, obviously. That's the basic of Kubernetes, right? So build a Kubernetes platform foundation. Make sure you create your CI/CD pipeline with help of Argo CD and Helm. The lesson here is that when you do these all changes, like team resist adoption, any new adoptions that team has a tendency to resist. So make sure that for that you use self-service templates. Phase 3 is migrate and validate. So gradual traffic shift to the new platform using Canary and blueprint deployment. Do not go for big bang, migration, right? All data should not be migrated at once. It could be a disaster. Compliance validation is critical. Performance benchmarking is also very essential, right? So these 2 things, compliance and performance, is very important. One important thing to know, particularly for regulated industry, auditors reject GitOps logs. So what you have to do, you have to still create compliance dashboard for them. And last phase is the AML platform. So definitely you have to make sure that these are very common in in modern cloud architectures, API first server interface, even architecture, GPU node pooling provisioning, model service infrastructure. So these 4 things actually develop the platform for expand your services into AI environment. Okay, quick one. AI and agentic architecture on modernized platform. How you do that? So it's not very complex, but this is the 4-layer architecture, right? So basically, from user interface data flow from better say request flow from top to bottom. At the same time, continuous learning loop flow from bottom to top. That is like, basically the key, the core idea of agentic, right? So let's understand these layers first. So user channels user data request comes through web portal, agentic desktop, partner API or mobile, right? And it invokes agentic orchestration layer for domain level decisions. So this agentic orchestration layer is nothing, it's like a multi-agent environment. Multiple agents are there. So here I give some example of agents like underwriting agents, document processing agents, policy decision agents, and claim agents, right? So I'm not getting into the details of the functionality, but you have to define your own agents depending on your domain. Maybe each domain may have to one agent or multiple, but it should be a multi-agentic layer, right? And it's an orchestration where agent will take the autonomous decisions, and that agents will use the AML services on Kubernetes. And these are the core of that AML services on Kubernetes that support the agentic orchestration layer, like LLM gateway connect models like GPT-4 or Claude, RAG pipeline that adds contextual knowledge, model servicing, right? Feature store that makes sure real-time data and feature computations, MLOps pipeline for training, evaluation registry, and basically maintain the model lifecycle management, right? So this is the third layer, and then it runs on the cloud-native platform that's also on Kubernetes, right? So what are the core principles of this cloud-native platforms? Microservices for core domains, service mesh through Istio, CI/CD through maybe Argo CD and Helm, policy enforcement, particularly for regulated industry policy enforcements, and attrition control through OP and K8s policy engine. Observability, very important. You have tools like Prometheus, Loki, Jagger, Grafana. So that's the whole architecture for AI and agentic to when you migrate the legacy service, you need to make sure that this architecture is established to expand AI in your new transform or migrated cloud service. So for me, this is the last page, and then I'll hand over to Samaresh. The business outcome, quick one. So the release velocity improved by 10x times from quarterly to weekly, or even sometimes nowadays even daily deployment is possible, right? 99.95% platform uptime from 97% with 10% self-billing, 40% cost reductions, and right size workload auto scaling. Next is 85% faster audits, because that all things are like evidence that you're collecting is like automated, not manual anymore. Less than 30% required, 30 minutes, sorry. Less than 30 minutes recovery time. Earlier it used to be like more than 4 hours for each incident. With help of K8 resilience, it is less than 30% self-recovery time, 30 minutes again. Self-recovery time, and 3x developer velocity because of self-service platform. This is the future path, what comes next. We were into 4 phases. Full agentic orchestration is the phase 1, phase 2. Then we need multi-cluster federation for scale. Third is edge AI for field agents is very important. Now everything is getting edge. And the last phase is autonomous policy processing. So this is like the basic, strategy. More like I talked about the strategy and the technical part. I'll hand it over to Samaresh for further.
Question.
Sure.
The measurable business outcomes. Okay, this of course is after the completion of this. So I have to ask, how long from start to having that was the time period?
So depending on the service that you have. If it is a small company.
No, I mean this 40% is not. Is this a random number, or is this a specific?
No, it's just an average.
It's a what?
It's an average cost reduction when you move to cloud from your legacy service. It's just an
this,
average industry.
This 40%. This was an actual company that had that 40%.
Yes. The actual company
So
that
the actual company that had that 40%. How long did the Kubernetes modernization project take for that company that then resulted in this?
That good question. So that probably I do not have the exact data. It is like average, and probably it say that today we are ending the legacy service, and that's the absolute data in legacy service. And then once we completely migrate to cloud, I'm just speculating here. completely migrate to cloud. Some company takes 1 year, some company takes 5 years. For example, USA is
I know you're saying some company, but you can also say some company takes 80% and some company takes 20%, this company took 40%. So because you know this company took 40%, surely you also know how long the project took for this company. Because you know 40%, you know 3x, you know less than 30 minutes recovery time, you know 85% fast. So you know all these specific things about the project outcome,
Okay,
but you
I understand your point. So I cannot tell you the average time that I need to dig into. But good thing, good point. You tell me. So I'll look into that actually. Okay.
Okay, thank you, Joyjit. So I'm going to take over the architecture part here. So this architecture looks convoluted, but actual architecture is even more convoluted than this one. So I try to get one simplified that I can present into the one page. So on the top you can see here this one you can see the deployment and platform. So this has all top levels like CI/CD, container things. This is called the and then we have enterprise architecture cluster. Here we have Istio service mesh, and then on the right side we have observability, where you can see the telemetry, Prometheus, Loki, Grafana, everything. So I'm going to explain each of these parts one by one. So it is hard to explain from this slide, this page. So this is the CI/CD pipeline and GitHub. So this is the easy. We can start from here. So deployment and platform team have two different repo. One is the app repo, where they can have the code, the health chart, values, etc. And then we have platform repo, where we can have the cluster add-on policies. So those two repos will be separate and owned by the different teams. So they cannot interfere with each other. So this team both will have the ownership about the code, and this team will have ownership about the platform. Then we have CI systems like GitHub CI/CD pipeline, you can say. So every new push to the Git repo triggers the automatic build. So project gets built first, then it runs the unit test and integration, functional tests, etc. And then it will create a signed Docker image of that application. And then we scan that image through the tree, and then that image gets stored into the container registry. So this container registry can be anything. One is the free one, if you want to use, can be the JFrog, or you can have the Harbor, where that you can use. Other one are provided by the AWS, and GitHub, Docker also provides the containerized storage to store the images. And then we have the Argo CD. This is to check this is basically to do the integrity check. So what happens in the normal scenario, when someone explicitly update the configuration file and deploy it through the kubectl command line, then what this Argo CD will do, it will check this, what is there into the GitHub, and what is there into the deployment. And it tries to look at what is the expected value and what is the current value, and try to match that. If something is different than this side, then it will reject, and it reject those changes and put this one back to the system. So you won't be able to accidentally update any configuration without updating this side. So all these changes happens through the development and proper code review process. So here is the cluster architecture. So all the traffic comes from this side. So through the web portal, through the agent desktop, through the partner API, basically the third-party application talking via REST API, GraphQL, or gRPC, not gRPC in this case, but of course the REST API and GraphQL. So all request goes to the load balancer first. So and here is the ingress gateway that receives the request and passes that to the Istio service mesh. Here you can see the namespace is the very important, because whatever this is how you can segregate the pods or application from one namespace to another. So under one namespace you can see we will have the various pods, various services running, and each one of those will have the resource quota, network policy, rollback, and same here you can see. So what happens, here services communicate with the services through the maybe the gRPC gateway, but here in this case service mesh, Istio service mesh takes care of, because this is a kind of works as a sidecar pattern, and they talk with each other if their policy is compliant. And again, under each namespace we limit the resources. So every services running under the pod will have some sort of resource allocated. So so that they don't have to contend for the resources from each other, whether it is available or not. So resources will be always available, and once they hit the limit, they cannot get the extra. So you have to plan that, plan to deploy the number of pods as per the resource limit. So network policy, L3, L4 traffic, all those services communicate with each other through the network via L3, L4 level. Then we'll have the role-based access control. So all the all the services they have so one service running in this domain cannot communicate with this domain. That is what the role-based access guarantees. So if it guarantees that okay they can communicate, then they will be communicating. Otherwise not. Then we will have this here admission control. Here you can say OPA, gatekeeper, and keyword for validating and the policy and generating the different rules. And then you can see API audit log, because all the API calls happens inside our service, that call needs to be logged. And then we will have this node infrastructure. We will have general node pool. All the common and simple services runs here that do not have the policy enforcement. All the regulated services goes here on the regulated node pool. They are trained with the regulatory with true no schedule symbol. And this is a vault to store the secrets. So all secrets get stored here. Kubernetes also provides Kubernetes secret to store the password and certificate, but this is the best way to do it. And here we have permanent persistence. This is out of Kubernetes cluster, so you can manage this storage externally. Going next. So the right side of the architecture is the observability. So all the requests from the Kubernetes cluster comes to the open telemetry collector, and then it goes, so all the matrix related information gets logged into the Prometheus, and then all the log information goes to the Loki or Splunk, what you can say, using those Splunk or Loki, you can do the filtering based on the pod, services, etc. Grafana is for dashboard. You can, this is for visualization. This is where user would like to see the service level objective. What would be the uptime or latency of my application? They have to define SLA and SLO. And this is the distributed tracing. So services talk to other services, right? So in the entire flow, you also want to know which service is consuming more time or taking more time, In case of, debug if you want to debug the latency, then this is very important. So Jaeger tracing, Jaeger provides a way to trace like which services are taking more time so that you can debug. And this is blameless postmortem. Basically, whatever wrong goes in any of those services, you are here to identify why that things went wrong and what we can do to improve that part. So yeah, so that's all about the architecture.
3 minutes, guys. Oh, nice.
So you can connect with us. This is left side Joyjit and right side me. This is our GitHub repository. Feel free to take a look. There are a lot of bunch of applications, libraries I have, and Joyjit also have. So yeah, feel free to check out the code and questions.
Yeah, I have one question. In one of the slides, you mentioned as a lesson that logs, ops logs for detecting whether compliance team, then you have to build a dashboard. So just want to understand, how did you connect these two logs? You just build a dashboard on top of the logs and then compliance team accepted those, or like how?
So there are a lot of like compliance tools that actually have that inbuilt compliance dashboard, right? So Guidewire for insurance, I'm just talking, right? Guidewire has that kind of tools, right? That you just need to plug and play. But if you want to actually really implement manually, right? I think, to be honest, right? Because nowadays that kind of work is really there, like you have to manually plug, develop an entire dashboard for compliance.
So you are aware of the SOC 2 compliance, right? So every company have their compliance team. Nowadays they are following the SOC 2 compliance as per their requirement and industry standards. So that is what you have to follow and apply the
I think he is asking how you do, right? How exactly, technical part you are asking, or?
No, just because you mentioned Kiros logs was rejected, that you have to build a compliant dashboard. That what information did you feed into those compliance?
Yeah, so mostly that is very
very
automated plug and play, but that's what I have seen. I have not, but if you want to develop something, right? So I'm just thinking what kind of tool you can use, right? But I mean, maybe I think I'm just thinking it's not all of a sudden coming in my mind because there are some tools. But if next 3 minutes or 5 minutes I come, get something I can do. Otherwise,
Give it up.
I'm really interested more about the OPA and pieces. Is that in the policy? Is that in your GitHub? Because you guys can really talk about that.
Is the OPA and Kubernetes stuff in your GitHub?
oh, the OPA and Kubernetes is not exactly in your GitHub, right? It could be at.
Is it in your GitHub for him to reference?
Oh no, in our GitHub? Oh no, it is not in our GitHub. We have not implemented that.
Because like,
It's more technical first, like.
How we're talking, your title said policy based, I was like thinking.
Yeah,
that's pretty more okay.
I am not having some, insurance domain that.
I just need to close it up. There's a couple of announcements.
Couple of announcements real quick. Is this the body? Yeah. And it's
Just a sec.
Hey guys, real quick.
If you guys don't have tickets for KCD, here's the QR code. I think we still have good prices. I think it's 75. $100. $100.
Discount code.
I think I've already.
Well, if you think we're gonna have,
Yeah, I did there.
I think we have a Kyverno
thing at the KCD, do you remember?
Doing
We
what?
have a Kyverno talk or workshop.
I don't remember.
Right, so I'm gonna give a shout out to Isovalen. They will have a special night with their facility, one night before KCDs for free. So if you wanna register,
It's their ED Quest event, so it'll be a hands-on workshop.
right. Got it? 1, 2, 3. Next month, April 23rd, save the date, gonna be at Zinga the Domain. Speaker, we always want to have you to talk.
Can you go back, what's the day again?
23rd.
Oh, yes, I will not be there.
Fourth Thursday, right? And picture time. Right.
Okay, great. I need some more.
If you need validation, come and see me. $8 validation. Oh, there you go. It's fine. Just take a picture, guys. Alright,
Picture time, guys.
guys, let's take a picture. It's important to show, to create FOMO.
And also,
Alright?
and also due to the CNCF that we actually have a meetup.
FOMO index.
For us to continue to be able to hold
The
these.
speakers.
Yeah, sorry.
The speakers. Guys, take a picture. Alright.
Bring it in.
Bring it in.
And these pictures aren't just for us, they're
That's
for
everybody.
all
1,
the other-
2, 3.
Kubernetes!
Yay.
You want up there?
Perfect.
Now,
Yeah, these pictures aren't just for the awesome.
Thank you.
Basically, the CMI can see, wow, Kubernetes meetups are a great idea.
Just gonna ask you guys to clean up after yourselves.
I might not be. Finish?
Feel free to take leftovers.
I'm just keeping my own functionality.
Thank you. You guys came from Dallas, right? This weekend we're running 20 miles. And my wife is coming from vacation, so next week she goes. I'm just putting the all this back. Oh, are they? Yeah.
The way it works now.
I do not have any company though, but this is what I told you, right? This is pretty common.
Yeah,
That's kind of a bit because I've been working on microservices, so that I know by heart. Right?
yeah, so
Yeah, it might, so this is blueprint, but you need to customize, you need to see, you need a strong architect, like see what is, that's why I said that those domains, I will define domains, I will define the microservices, and the communication between that code, like you want to say, I'll send you the slide, right? I'll send you the slide, and if you need something, LinkedIn, you, when you no, I'm here, no, sir, no, otherwise, too much.
Yeah, that was funny, that's when the annotation, I didn't know. $56 tokens a second. But then, if you run 5 conversations, you get. Well, that's why you want to do like K8s. And then also
This is your whole lot of years.
my whole lab is not like. But it would be. I know. I think so all that stuff is purely architecture. Like the first time I did it, I did something like literally was like a method. Basically, the idea works. If you can get all those shares online, sometimes because of the like calling, like adding context, and then it made the call.
Because people read, okay, I wanna do it, but you wanna, what are they doing? So at my, my current, well,
They say they're done,
so,
but they're quantized.
like, all the experience you have in the next year the KCD, you guys can bring all this experience you
Oh, yeah.
Alright,
So,
time to go home.
alright, gotta get out of here.
Yeah.
Guys, we gotta get out of here.
Yeah. That's what the deal is.
But again, I've spent the last 2 years validating the strategy. About it. But I'm not, just to be clear, I'm not looking for money, I'm looking for something more valuable. I'm looking for time. I'm looking for time and expertise, which is actually more valuable, and essentially a runway. And I don't necessarily, you know, as founders, especially in a startup position, you know, it's a little fuzzy, because everybody's runway is
parking tickets kept here, I forgot to grab parking.
That's fine.
But I cannot get
Was it worth for like, just taking picture and scanning?
Okay, thank you very much. Okay, bye.